Good morning, dear students. A warm welcome to all of you for our today's digital session for the subject Science and Technology, both section A and B. From Monday onwards, we have started with our revision sessions for the upcoming third assessment exam, which is going to begin very shortly. On Monday, we have started with the revision of chapter number 18, Observing Space with the help of telescopes. Last topic of revision is remaining, that we will complete today, and then we will revise chapter number 13, Carbon, an important element. So let us start with the revision of the last topic for chapter number 18. In chapter number 18, we have started with the revision of the different types of telescopes, the optical telescopes and the two type of reflecting telescopes, Newtonian and Cassegrain. We have seen which type of mirrors. As you know that in reflecting telescopes, the mirror is replacing the lens which was used in refracting telescope. As you know, there were different difficulties which were faced in using the refracting telescope and how they were overcome to a certain extent when the mirrors was used in place of lens that we have seen last time. The next type of telescope which we are going to study today is the radio telescope. Radio. I have told you that different heavenly objects, they emit different types of waves. They emit radio waves, microwaves, infrared waves, ultraviolet waves. So out of that we are going to study about the radio waves. So many heavenly objects, they emit radio waves in addition to the visible radiation. I had told you what is the visible light rays when they fall in the wavelength between 400 nanometer to 800 nanometer. Then we can say that it is visible radiation. So there are many heavenly objects which emit radio waves in addition to the visible radiation and cannot be seen with our eyes, and hence a special type of telescope is used to receive this rays, which is called a radio telescope. In the beginning of the chapter, I had told you that one single type of telescope cannot suffice the needs to study about the different heavenly objects in the space. So different types of telescopes are required for studying or exploring the entire space. Now this radio telescope, it is made up of one or more dishes of a particular parabolic shape. You can see here in the figure. As in the optical telescope, the incident radio waves, they are reflected by these dishes and they converge at the focus. Then you will see a radio receiver is placed at the focal point. The information which is gathered by this receiver is passed on to a computer. The same technique you can see as we have studied in sonography. In sonography, we have studied how the ultrasonic waves, they travel from the probe. They take the images of the different organs, come back to the probe and then fed to the computer, and then you study it. You have seen how high frequency ultrasound transmitted inside the body with the help of the probe. Then the sound reflected from the internal organ is again collected by the probe. So similar type, little bit similar is the technique over here. Then whatever information is gathered by this receiver, it is passed on to a computer which analyzes it and then constructs the image of the source which you have to study. The main radio telescope which you are going to study in details in your syllabus is the feather in India's cap, that is GMRT. It is the large radio telescope, giant telescope, which is called the Giant Meter Wave Radio Telescope. The full form of GMRT is Giant Meter Wave Radio Telescope. It has been erected in Narayangaon near Pune, and it uses this radio waves having wavelengths of about a meter, which are coming from the planets and stars to study about those heavenly bodies. Now, why this is called a giant telescope? Because the arrangement of the 30 dishes over an area which measures up to 25 kilometer across, it is made in such a way that it works as a single dish having a diameter of 25 kilometer. You can see a figure, an image of GMRT I have placed from the Google net for you to have a proper idea. Now this GMRT, it gives the same data that we would have got from a telescope having a single dish which is spread of about 25 kilometers diameter. Who has made this GMRT? Why I have told you that it is the feather in India's cap? This GMRT is the radio telescope which has been made by our Indian scientists and engineers, that too at a very minimum cost. And the main pride for India is this GMRT is a world standard research facility. Scientists, they come to India to study about the solar system, the solar winds, pulsars, supernova, interstellar hydrogen clouds, etc., etc. with the help of GMRT. See, our Indian scientists, they have prepared such a big radio telescope in India without spending more money on the expenses. So by making minimum cost, and also they have made it in such a way that it is declared as a world standard research facility which invites the scientists from all over the world to come in India and make use of this GMRT. So after we complete the topic of radio telescope, we complete with the study of the different telescopes which are there in your syllabus in this chapter. Now, our next topic is telescopes in space. See, one more image of GMRT I have put here. Many pictures, many images. If you search on the Google net, you will be able to see about the GMRT. Telescopes in space. Now, visible light and the radio waves which are emitted by these heavenly bodies in the space, they can pass through the Earth's atmosphere and they can reach the Earth's surface, and hence the optical and radio telescopes can be erected on the surface of the Earth. They are erected on the surface of the Earth, but this Earth-based telescopes, they have some problems in making good quality observations about the heavenly bodies. Now, which are the difficulties which are faced by the optical or the radio telescopes when they are erected on the Earth's surface? One is, you know, that the visible light which is coming from the heavenly body, you can see visible light coming from the heavenly body, it has to pass through the Earth's atmosphere to reach the Earth's surface. And what happens during this journey? Some of the light is absorbed by the atmosphere, and hence the intensity of light which is reaching the Earth's surface, it decreases to a certain extent. See, the visible light is traveling from the heavenly object. It has to pass through the Earth's atmosphere. Some part of the light is absorbed, and hence whatever brightness, whatever intensity of light you have to receive is not received in proper amount. Also, some of the, you can say, second problem is due to the changes in the atmospheric temperature and pressure which is seen constantly. Now this changes, they cause turbulence in the atmosphere, which in turn cause the light rays to change their path slightly and shaking the position of the image we have to receive from the heavenly object. Not only that, other drawbacks are because of sunlight. We cannot use the optical telescopes during the day. Also during the night time, city lights and cloudy weather can cause difficulties in observing the heavenly bodies. See, to study about these heavenly bodies, you should get a correct image of them. And so many difficulties which you have seen up till now, that the position of the image can shake, or some of the visible light is absorbed, so the intensity is decreasing. So all these difficulties does not enable us to get a proper image of the object. If you use the optical telescopes during the daytime, then sunlight is going to interfere. If you use during the night time, the cloudy weather, the city lights are going to interfere in getting the proper images, and hence to reduce these problems, optical telescopes are situated on the top of the mountains at in uninhabited places. So from there at least you can study about the objects clearly. But if really you want to get rid of all these above problems very completely, you should place the telescope above the Earth's atmosphere in the space itself, because all these problems won't exist in the space, and thus the image which is obtained by the space telescopes would be very bright, very clear, and they will remain at one place without shaking. So if you erect these telescopes in the space itself, then you will be able to get a proper image of the heavenly body which you have to study without any such type of difficulties or interferences which are seen when the telescopes are erected on the Earth's surface, because atmosphere is totally different over there on the Earth's surface. And now this idea, scientists, they have started turning this idea into reality. Means what? The procedure of putting the telescopes in the space have begun. Now about the ISRO, that is Indian Space Research Organization, the institute which was established in the year 1969 with the aim of developing the technology for making and also launching of the different artificial satellites. Till today, till date, ISRO, it has successfully launched a large number of satellites, and ISRO's program is foremost among the successful programs which are undertaken by our nation, that is independent India. And India's progress in space science, it has played a big role in the national and social development. ISRO, that is Indian Space Research Organization, has its main headquarters at Bangalore. You can see the image over here. Now the different types of series of satellite we are going to study in short. More information about it you are going to study in the next year, that is the 10th standard, when you study chapter number 10 from section is space missions. The first type of satellite series is INSAT and GSAT, which supports our telecommunication network, television, broadcasting, meteorological services including your network, mobile systems, TV, etc. It is because of this series of satellites that the telephone, television, internet services, they are available everywhere in the country. The next series is AstroSAT. This satellite is exclusively used in the field of education. The word itself tells you AstroSAT. So satellite related to education. The IRS satellite is used for monitoring and management of the natural resources, as well as also the different types of disaster management. And more in details about ISRO you will be studying next year. The last topic to end with the revision of this chapter is AstroSAT. AstroSAT. In the year 2015, our nation, India, ISRO, that is Indian Space Research Organization from India, it launched an artificial satellite which was named as AstroSAT in the space. The unique feature of this satellite was it has ultraviolet, that is UV and X-ray telescopes and detectors, and most of the parts which are used in this satellite, they are made in India. It is a unique system having different kinds of telescopes on a single satellite. Different telescopes on a single satellite, something unique, something different, and hence our Indian scientists, they are studying the various aspects of the universe by using the data obtained with the help of these different telescopes which are erected on a single satellite, and the name is AstroSAT. With this, we complete with the revision of chapter number 18, that is observing space with the help of telescopes. Now it's your time how you are going to study, textual exercise, additional questions, activities, everything is discussed to you. Now without wasting time, we will start with the discussion, we will start with the revision of chapter number 13, carbon, an important element. Why carbon is an important element? That I have already told you that the element carbon, it is available abundantly in nature. It occurs in the free as well as in the combined state, but not these properties, but most of the things in nature, including your foodstuffs, clothes, medicines, fuels, etc., etc., they contain carbon in it, and hence it makes carbon categorized as an important element. Now we will see the different symbols, atomic number, atomic mass for carbon, the different concepts related to carbon. Symbol of carbon is capital C, atomic number 6, atomic mass 12, electronic configuration 2 electrons in the first shell, 4 in the second shell, making valency of carbon 4. Now, as I have told you that compounds which are obtained directly or indirectly from plants and animals, they are called as organic compounds, and those which are obtained from minerals, they are called as inorganic compounds. And you have to keep in mind, because next year in 10th standard you have an entire chapter in section A, carbon compounds. So all the organic compounds in nature, they contain carbon. Not only that, carbon is the main element in cellular DNA and RNA that transfers the hereditary characteristics from one generation to the next. Now more in details about DNA and RNA we are going to study in chapter number 16, that is heredity and variation. Now the occurrence of carbon, as I have told you earlier that carbon in the free state, it occurs in both free state as well as combined state, and the name carbon, it is derived from the Latin word carbo, which means coal. Now in the free state, it is found as diamond and graphite, and in the combined state it is found in the following compounds as carbon dioxide in the form of different carbonates, fossil fuels, carbonaceous nutrients, natural fibers. So many examples they have given to us. Next topic is the properties of carbon. The very important, a unique property exhibited by carbon is the allotropic nature of carbon. Allotropic nature. What do you mean by the term allotropy? Some elements in nature, they exist in more than one form, and here the chemical properties of these different forms are same, but physical properties are different. Physical properties vary, and this property of elements is known as allotropy. Apart from carbon, there are different elements like sulfur, phosphorus, which also exhibit this property. Now, the allotropes of carbon, we are going to study in our syllabus in this chapter the crystalline forms and the non-crystalline forms of carbon. Today we will complete with the crystalline forms, its properties, and the different three crystalline allotropes. Now crystalline forms, word itself tells you that there is some definite arrangement of atoms in the form of a crystal. So the first property is it has a regular and definite arrangement of atoms. High melting and boiling points are possessed by them, and they have a definite geometrical shape, sharp edges and plane surfaces. This can be a direct question in the exam. Give the properties of crystalline forms of carbon. Now carbon, it has three crystalline allotropes. The first one is diamond, second one is graphite, and the third one is fullerene. So all the three we are going to study in details one by one. Now we are just going to revise because already study and explanation is over. Diamond. The word itself, the name itself, it attracts especially the woman. These diamonds are found in our nation in India, mainly in Golconda and Panna, that is Madhya Pradesh, and they are also found apart from our nation in different countries like South Africa, Brazil, Belgium, Russia, etc. Now about the structure of diamond, as it is a crystalline allotrope of carbon, it has a regular definite arrangement of atoms. So in diamond, if you see, every carbon atom is bonded to four neighboring carbon atoms by covalent bonds, and due to this three-dimensional structure, diamond becomes very hard. And so the first property of diamond, before going ahead, I had just given you the image of the diamond, Kohinoor diamond. Once upon a time, India was famous for the Kohinoor diamond. This diamond, it was found in the 13th century in the mine at Guntur, Andhra Pradesh, and weighed about 186 carats. This is just additional information for you to know. Now let us peep into the properties of diamond. Brilliant and pure diamond is the natural hardest substance having a density of about 3.5 grams per centimeter cube. Melting point of diamond is 3500 degrees Celsius. When diamond is heated at 800 degrees Celsius in the presence of oxygen, only carbon dioxide is given out as the product. No other product is formed. Why only carbon dioxide? What do you mean by diamond? Diamond means carbon indirectly. So when carbon is heated in the presence of oxygen, carbon reacts with oxygen forming carbon dioxide. It does not dissolve in any solvent. Neither acids nor bases have any effect on diamond, and it is a bad conductor of electricity because it does not have any free electrons which are required for the conduction of electric current or electricity. So these are the different properties. You have to remember each and every property. You have to study, especially the density, melting points, because it can be asked under MCQs. Next uses, I don't have to discuss. Diamond, word itself tells you they are used in ornaments. They are very hard. It is the hardest natural substance, hence used in glass cutting, rock drilling machines. Diamond knives are used in eye surgery. Diamond dust is used for polishing other diamonds. Not only that, diamond is used to make windows, giving protection from the radiation in space and also in artificial satellites. Apart from this, any other use from the Google net or which you know, you can write on your own in the exam. The next crystalline allotrope of carbon is graphite, which is found in the natural state in Russia, New Zealand, America, and our nation, India. The lead which is used in pencil, it is made by mixing graphite with clay, and this process it was discovered by Nicholas Jacques Conte in the year 1795. About the structure of graphite, if you look at it, every atom, every carbon atom you can say in graphite is bonded to three other carbon atoms in such a way that a hexagon means six sides, hexagonal layered structure is formed. Now this graphite crystal, it is made of many sheets or layers of carbon atoms. The layers which you see when you cut an onion, the layers which you see, same way you will see the layers of graphite. These layers, they slip over each other on application of pressure, and each layer, one layer of graphite is called as graphene. About the properties of graphite, they are, you can say, very much contradictory to the properties of diamond, because diamond, you know its appearance, whereas graphite, it is black, soft, brittle and slippery. Diamond is hard, it has a shine, whereas graphite is black, soft, brittle, slippery. Diamond is a bad conductor of electricity, whereas graphite, inside each layer of graphite, free electrons move continuously, and making graphite a good conductor of electricity. Can be used for writing on paper, whereas diamond is used for making ornaments. Density of graphite is 1.9 to 2.3 gram per centimeter cube, whereas for diamond it is 3.5 gram per centimeter cube, and graphite does not dissolve in most of the solvents. This property is common for both. About the uses: used for making lubricants, carbon electrodes, pencils for writing, paints and polish, and used in lamps which give a very bright light. That is, they are used in arc lamps. So here we end with the revision of properties for both the crystalline allotropes, that is your diamond and graphite. The third one is fullerene. I have told you, you don't have to study much in details for this. Only you have to revise the properties and uses for fullerene. It is also an allotrope of carbon, but very rarely found in nature. These are the different examples of fullerene. It exists in two different forms. One is in the form of buckyballs. Here you can see buckyballs. In images I have shown you bucket tubes also. So when the fullerene exhibits, it is spherical, round, then you call it as buckyballs. Why? Because they resemble the balls which are used in soccer balls. They are resembling, and when they are found in the cylindrical state, they are referred to as bucket tubes. The cylindrical fullerene structure, it is called as bucket tubes. Now about the properties of fullerene. The first property is molecules of fullerenes. They are found in the form of buckyballs, bucket tubes. There are about 30 to 900 carbon atoms in one molecule of fullerene, and they are soluble in organic solvents such as carbon disulfide, chlorobenzene, etc. Properties you have to learn it by heart. Uses for fullerene are: first uses, they are used as insulators, that is the substances which do not allow the current to flow through them easily. They are used as a catalyst in water purification. You all know the meaning of catalyst, a substance which by its mere presence, it alters the rate of a chemical reaction, means it allows the chemical reaction to take place at a faster rate without interfering with the reaction. That is known as catalyst. And third use is at a certain temperature, fullerene exhibits superconductivity. What do you mean by the term superconductivity? It is the ability of certain metals to allow electricity to pass through them without any resistance at very low temperatures. That is the meaning of superconductivity. So at a certain temperature, this fullerene, it exhibits this property of superconductivity. Today we will end our session revising the crystalline allotropes of carbon. In our next session tomorrow, we will continue with the revision of this chapter, the non-crystalline or the amorphous forms, and then the topics ahead, that is about the hydrocarbons and about methane and biogas plant. If time persists, retains tomorrow, then we will continue with the revision for chapter number 12 from section A, that is study of sum. So I request all of you, when you attend the next session, at least go through the topics, read the topics, because your assessment is very near now. And I have told you, each and every exam, whether you attempt it online, whether you attempt it offline, that doesn't matter. How much you are taking the efforts, each and every exam, take it as a challenge and a step towards your board exams for the next year. Do not underestimate any exam key. The pandemic is going on, so we will take the exams lightly. Don't do it. Each and every example you take it, each and every exam you take it very seriously, and your preparations should be up to the mark. Thank you, dear children.